In this method, we're going to do more of a trial and error than other types of methods. So in this, what we'll do is we will look at two numbers that multiply together to give us the leading coefficient. Here that's 6. In general, the leading coefficient is the number in front of x squared. We also need two numbers whose product is negative 40. So let's list those out. So the two numbers that will give us positive 6 will be 1 and 6, or 2 and 3. Two numbers that would give us negative 40 could be negative 1 and 40, so I'm just going to write the positive factors, 2 and 20, 3 doesn't work, 4 and 10, and then 5 and 8. Those are the possible factors. Now I notice that the constant term is negative, so one of these two numbers over here is going to have to be negative, the other will be positive. And now I just start trying to pair things up. So maybe I would try something like x and 6x. Where did those numbers come from? They came from this pair of numbers. I might also try instead 2x and 3x. Where did those come from? They came from the other pair. Now what we need to do is we need to insert these numbers in here to see which combination will give us a negative 40 and a positive x in the middle. This will require that we review our little FOIL method as well. We're looking for when the product of the inner terms and the product of the outer terms adds up to positive 1 that's in the middle there. So I could try various things, but as I do it, I'll show you things that you cannot do, that you definitely don't want to do. So for example, I could try 1 and 40, but I wouldn't want to do that. And the reason I don't want to do that is because the original quadratic that we have here has no common factors between 6, 1, and negative 40. I just put 6 and 40 together, which have a common factor of 2. If the original one doesn't have common factors, then the factors themselves won't have common factors. So that certainly would not be what we want to do. So we erase those and start again. I can also see now that 2 and 20 will be a bad choice because either 2 would go with the x and 20 with the 6, which would have a common factor of 2 over here, or I would put the 2 with the 6, which wouldn't work either. 4 and 10, for the same reason, I'm going to put 4 or 10 with the 6x, and of course those have a common factor, so I wouldn't do that. Finally, I might try 5 and 8. The only way I could do that, I wouldn't put the 8 with the 6 because it has a common factor with 6, and so I might try to put the 8 over here with the x and the 5 with the 6. When I multiply these things, I'm going to look at the product of the inner two terms, which will give us 48x, and I would look at the product of the outer terms, which would give us 5x. One of these needs to be positive, one needs to be negative, but no matter how I choose the signs, there's no way that I can combine 48x and 5x to get x. So this is not going to work for us. That means if it's going to factor, it's got to factor as 2x plus or minus something multiplied by 3x plus or minus something. I can continue as I did before, picking one pair of numbers that multiply to give me 40, putting them in, and then seeing how I might combine them to get the x that's in the middle. If I try to put 1 and 40 in, I could put 40 with the 2, but again, if I do that, then 2x and 40 have a common factor of 2. So if I do 1 and 40, it's going to have to be 1 with the 2 and 40 with that. Now I'm going to look at the combinations. 1 times 3x is going to give us 3x. 2x times 40 is going to give us 80x. Those two together cannot give us the x in the middle, so that won't work. Now let's try 2 and 20. But if I try 2 and 20, either 2 will have to go here with the 2x, which would have a common factor with that 2, or 20 would have to go with the 2x, but again 20 and 2 have a common factor, so that won't work. So 2 and 20 is out. We've already eliminated 1 and 40, 2 and 20. For 4 and 10, we have a similar problem. If 4 goes with the 2, we have a common factor of 2. If 10 goes with the 2, we have a common factor. So that can't be it. We have one choice left, and if it doesn't work, then this doesn't factor. I have to put 5 and 8 in here. If I were to put the 8 with the 2, I'd have a common factor. It must be that the 5 goes with the 2 and the 8 goes with the 3. Now I try the different products, the inner product and the outer product. The inner product will give us 15x. The outer product will give us 16x. 15 and 16 are 1 apart, and so in order to get the positive in the middle, I want a negative 15x and a positive 16x, which means we need to put a plus with the 8 and a minus with the 5. And that would be the way we factor that one. For our next problem, we're going to look at 4x squared plus 15x minus 54. Once again, we're going to look at the leading coefficient, find two numbers that multiply to give us 4. Those would be 1 and 4, or 2 and 2. Now we need to find two numbers whose product is negative 54. But again, I like to just focus on the 54 and worry about inserting the negative later. So 1 and 54 will definitely be one possibility. 2 and 27. 54 is divisible by 3. It's 3 times 18. And then the next number would be 6 and 9, and there aren't any other ways to get 54. Once again, we're going to take the two factors that got us the 4x squared there, and we're going to multiply either x and 4x to give us the 4 coefficient, or 2x and 2x to give us the 4x squared. I can once again try to put the different factors in, keeping in mind that I should have checked at the beginning we have no common factors between 4, 15, and 54. If I don't have any common factors there, when I put these numbers in, I cannot put numbers that have common factors with 4. So for the first one, I can't put the 54 in with the 4x, but I might try to put the 54 over here and the 1 there. Now what I will do is I'll find the product of the inner, that's 216x, and the product of the outer, which will just give me x. We can't combine 216x and x to get us the 15 that's in the middle. We'll have to find a pair of numbers whose difference is 15. We say difference because the coefficient over here is negative. So that first one is out. Now we can try 2 and 27. Where can 2 go, or where can't it go? 2 can't go here with a 4, so if we're going to do this, we would have to have 2 here and 27 here. But once again, if I try the product of the inner terms, we're going to get 8x. If I do the product of the outer terms, I'll get 27x, because once again, this is a negative. The difference between these two is going to have to equal 15, and that doesn't happen. So we can eliminate that as a choice for this particular pair of numbers. We move on to 3 and 18. 18 and 4 have a common factor, so certainly the 18 can't go with the 4, so the 18 is going to have to go with the x. We'll put 18 there. And if we put the 3 over here, we would, when we find these products, we'll get 18 times 4, which is 72x, and 3x, 3 times x, which would give us 3x. The difference between these two numbers is 69, which does not give us the negative 15 in the middle. So that doesn't work. We can eliminate that as a choice. Finally, we have 6 and 9. 6 and 4 have a common factor, so we can't put the 6 over here. If it goes anywhere, it's going to have to go with the x, and then the 9 would have to go with the 4. Now we try once again. We take the product of the inner 2, and we take the product of the outer. 6 times 4 is going to be 24, so we'll get 24x. X times 9 will give us 9x. And there we have it. 24 and 9 combined to give us the 15 that's in the middle. But we want a negative 9, and the only way we can get a negative 9 will be to put the negative with this 9 and a positive with that. And so our factorization will be x plus 6 times 4x minus 9. Things are getting worse, bigger numbers, right? So now we're going to have to find two numbers whose product is 12, and then two other numbers whose product is 15. What's really nice about this is these numbers are going to multiply to give us a positive number. The sign in the middle tells us what kinds of numbers we need. If two numbers multiply to give us a positive, they're either both positive or both negative. In this case, they're both going to have to be positive. So I start thinking of pairs of numbers that multiply to give us 12, 1 and 12, 2 and 6, 3 and 4. What numbers multiply to give us 15? 1 and 15, 3 and 5. So I basically have 3 choices for what's going to go at the beginning, 2 choices for what goes at the end, and so we start playing around. So we maybe try x and 12x and see what we get from that. If I try to put 1 and 15 in, 1 would have to go with the 12x because the 15 and 12 have a common factor. Let's try that. So I will have 15 here, 1 there. If we do the inner product and the outer product, they're going to have to combine. Since this is a positive value here, we're going to have to add them to get 92. Well, 15 times 12 is already 180. That'd be 180x. And then 1 times x is just going to give us x. When we add those two, we don't get 92. Not going to work. We can now try 3 and 5. If I put the 3 in, it can't go with the 12 because it has a common factor with 12. So 3 is going to have to go with x and 5 with the 12. When we compute the inner product, we're going to get 36x. When we compute the outer product, we're going to get 5x. 5x and 36x is going to give us 41x. Again, that won't work. This means that if it factors, it won't factor with x and 12x. So we move on to the next pair. We could do 2x and 6x. Now we want to put 1 and 15 in here. Give that a try. If I put 15 in, 15 once again can't go with the 6x because they would have a common factor of 3. And so the 15 would have to go with the 2, and then the 1 would have to go with the 6. The inner product is going to be 15 times 6, which is 90x. And then the outer product is going to be 2x times 1, which is 2x. Because, once again, they want to add up to negative 90 or to positive 92. If we do pluses with both of these, we get exactly what we want. So we would do a plus here with the 6x plus 1 and 2x plus 15. And it gives us the 92x in the middle. One more example. One thing that's very important is when you look at a problem, you want to make sure that there are no common factors between all 3 terms. I certainly see that each term has x to some power in it, so we can factor an x out. But I also see that all of these are even numbers, and so we can at minimum factor out a 2. If I'm not sure how much I can factor out, I'll factor out a little bit, see if the remaining ones have any common factors. So let's factor out a 2x and see what happens. We'll end up with 2x. This will give us 9x squared plus 100, or not 100, but 68x minus 32. Now I look to see if there's anything else in common. 9x squared, or 9, has factors of 1, 3, and 9. Neither of the other 2 factors have a factor of 3 in it, so this doesn't factor any further in that respect. But now we once again need to find 2 numbers whose product is 9. It could be 1 and 9, or it could be 3 and 3. And then we need to find 2 numbers whose product is 32. So 1 and 32, 2 and 16, or 4 and 8. We notice once again that the constant term is a negative value, so one of these factors is going to have to be negative, one will have to be positive, which means the difference between the inner product and the outer product will have to be the number that's in the middle. Now we want to be super careful. The number that's in the middle here is 68, so that's going to be our target value here, not the 136 that's in the middle above. So let's try different factorizations. We might have 2x times x and 9x here using the first pair of factors, or using the second pair of factors, it might be 2x multiplied by 3x and 3x. 2x, 3x, and 3x. We try these different values. So I'll put 1 and 32 into one of these factors. Now the thing about 32 is 32 doesn't have a factor with 9. 32 doesn't have a common factor with 1. And so we might try 1 and 32. We might also try 32 and 1. We'll have to try each if the first one doesn't work. So let's try 1 and 32 first. When I find the product of the inner terms, we'll get 9x. When I find the product of the outer terms, we're going to get 32x. The difference between those is 23, which is not the 68 that we're looking for. So we're going to have to try something different. Let's try switching the 32 and the 1. Now when I multiply the product of the inner terms, we'll get 288x. X times 1 is going to give us x. The difference of those is 287x, not the 68x in the middle that we need. So that did not work for this particular pair of numbers. Let's cross that off. We got both of those combinations. Now let's try 2 and 16. I'll first try the 2 with the x and the 16 with the 9x. If I do the product of the inner pair of numbers, we'll have 18x. The product of the outer two will be x times 16, or 16x. The difference between these two numbers is going to be 2x. Again, not the 68x that we wanted. So we'll switch the 2 and the 16. When I switch those and multiply the inner terms, we end up with 144x, not looking good, and x times 2, or 2x. The difference between those is 142, which is a far cry from the 68 that we're looking for in the middle. We try again. We've switched those, so that rules out those numbers being combined. So now let's try 4 and 8. I put the 4 with the x, the 8 with the 9x. The inner product is going to give us 36x. The product of the outer terms is 8x. The difference between those is 28x. We're looking for a difference of 68x. That doesn't work either. We try now swapping the 8 and the 4. When I swap the 8 and the 4, the product of 8 and 9 is 72, so we have 72x. The product of x and 4 is 4x. Remember, one of these will be positive, one will be negative. We want the difference of these numbers to be equal to 68, and this is the magic pair of numbers. If we do a minus 4, that would mean we'd have to have a minus there and a plus there. We've found our particular factorization. This factors as 2x times x plus 8 times 9x minus 4.